welcome back to Data Architecture Day. We are getting close to the home stretch. We have a few more sessions to go, excellent sessions to go. The first of our remaining excellent sessions, Angela Henry will be talking to us about data modeling. So if you'd like, please take it away.
Great, thanks, Kevin, and thanks for organizing this. This is awesome. I'm really excited about seeing all the people from the community putting all of these virtual events on. Being a speaker, that's part of my socializing is being able to attend events in person. And if I can't do that, well, this is the next best thing. So thank you so much for organizing this and for selecting my session. So. My session is getting started with data modeling, as Kevin said. I am going to put a disclaimer out here. So the title says getting started. So if you have been working in data modeling for over a year, you're probably not going to get a whole lot out of this session. The session is intended for people who want to get started in data modeling. They don't know a whole lot about it. So there's my disclaimer. Quick bit about myself. That's me, Angela Henry. I live in High Point, North Carolina, so I'm just a stone's throw away from Kevin. I'm waving. He's waving back at me. It's only 70 miles apart, but he can see me. I know he can. I am a solution architect at Blue Granite. Blue Granite is a consulting company based out of Kalamazoo, Michigan. That holds no significance other than I like to say the word Kalamazoo. I think it sounds funny. So we specialize in BI, modern BI kind of stuff. We're a cloud first, but not cloud only company. So if you need some BI work done, come to Blue Granite. We'll get it done for you. I am a data platform MVP. I do tweet on Twitter. My handle is SQL Swimmer. And why? Well, not only am I a swimmer, but I'm also a coach and instructor, and I'm going to take 10 seconds to get on my soapbox here. If you do not know how to swim, please learn. It is the only sport that can save your life. And if you think as an adult you cannot learn how to swim, you're absolutely incorrect. There are instructors like myself who are specially trained through US Masters to teach adults how to swim, because teaching adults how to swim is very different than teaching children how to swim. But I do also teach children how to swim, and I do also coach swim team. So there's my soapbox. I'm putting it away, moving on. This is a brand new session that I have created. I have a QR link right here. And Kevin's going to put it in the chat at the end, but just keep in the back of your mind, this is brand new. I would really, really like your feedback on this. So please do that. If you think the session was awesome, fabulous, that's great. If you think it sucked, well, I'm sorry, but tell me why you think it sucked. I hope it doesn't, but if it does, you got to tell me why. All right, what are we going to talk about today? Well, first we're going to define what data modeling is. Then we're going to talk about some of the benefits of data modeling. And then we're going to walk through a very simple example on how to get started with data modeling. But first, it's selfie time. So when I teach classes in person, I normally take a picture of myself with my class, and then I put it out on Twitter because, not everything is real until you put it out on Twitter. So that's what I'm doing. You put it in social media, and that's how it works. All right, I have put it out there. Fabulous. Let's keep going. If you would like to take a picture of yourself learning today, do that. Put it out there on Twitter. I miss seeing your bright, shiny faces. So do that for me. All right, we're going to keep going. Defining data modeling. But before we can define data modeling, we have a little bit of database history that we have to talk about. So back in the good old days, there were navigational databases. And then we graduated to relational databases, and then we became, full circle and back to analytical so that we could actually analyze that data. So a quick bit about navigational databases. So navigational databases, think COBOL. When computers were first invented, the media that we had were tapes, reel-to-reel tapes. Everything was sequential. So it was really hard to get data out in a timely and easy fashion. So when they came up with hard disk drives in the late 60s, they said, yeah, tapes are, that's an outdated way of trying to access that data. We need a better way. So step in E.F. Codd, who was working for IBM at the time, and in 1970, he came up with relational databases. So relational databases are going away from trying to access that data sequentially. Codd was very disgruntled with the performance that he got with navigational databases. So the relational databases, it's the concept of storing things in a tabular format. You have tables of data that have rows and columns, and then you relate things together with keys, and hence you get a nice relational database. Things about relational databases that we need to know: they are normalized. So what does that mean? That means that we're trying not to store redundant data. We don't want to store the same data more than once. And there are rules for normalization. And if anybody was in Lewis Davidson's session earlier today, he was talking about relational databases and normalizing databases and all that kind of stuff. And he's one of the experts in the field when it comes to relational databases. Relational databases are really good for highly transactional systems. So it's lots of single write and update statements. That's what relational databases are really good at. You typically use structured query language to access the data in relational databases, SQL, and it's optimized for those tiny writes and updates. So it's not really good with the read operations, and so it's not optimized for that. And typically there are very few read operations anyway, because you're just doing those little tiny inserts and updates. So think of point of sale system, manufacturing, credit card processing. Those are all really super tiny transactions that are out there. Well, that's really good, but what happens when we want to get that data out? It's super complicated. We have like 20 tables that we have to go get data from. And that's where analytical databases come from. We want databases that are more optimized for reporting. And that's really kind of what analytical means, for reporting purposes. So these databases are denormalized. So we're kind of going backwards. And instead of trying not to store the same data more than once, we might store the same piece of data multiple times, because it's going to make it easier. The other thing about analytical databases is that they're loaded in bulk at regular intervals. So with our transactional databases, remember we were doing, thousands, millions of tiny little single transactions. Well, with your analytical databases, you're typically taking data from those transactional databases and loading it into your analytical databases at a regular interval, whether that's hourly, daily, weekly, monthly, whatever. The languages that are typically used with these, you're looking at MDX or DAX. MDX stands for multi-dimensional expressions, and DAX, depending on who you ask, either stands for data analytic expressions, data analysis expressions. Either way, we're looking to analyze the data using expressions. And these analytical databases are optimized for read operations, not for write operations, but for read operations. So think data warehouse. We want to take all of the data from all of our disparate transactional systems, dump them into a warehouse so that we can analyze it and report on it. Two of the most common data modeling use cases are either for the transactional system or the analytical system. What we are going to talk about today specifically is for the analytical system. And when you model for an analytical system, it's dimensional modeling. Yay! This is like my favorite thing to do. I love doing this. I do come from a DBA background. I was a DBA, actually I was an application developer, then I was a DBA, and now I've been working in BI for about 10 years, and I absolutely love dimensional modeling. And that's what we are going to focus on today. We have some common dimensional models that are out in use in the wild today. There are two schools of thought, mostly two schools of thought. You have Inmon and you have Kimball. I am Team Kimball all the way. Let's talk about these a little bit more. So the Inmon method, this was the first method that was really out there. And this is what the first data warehouses were built upon. These take a top-down approach. You look at the entire organization and you figure out what you need, and it's more of an entity relationship-oriented design. And it's highly normalized. It's third normal form. So if you listen to Lewis Davidson's session earlier today, he probably talked about third normal form. Whereas the Kimball method, this was named after Ralph Kimball back in, I think, about 1980 or so. He looked at all of this stuff and he said, you know, it's getting really complicated to get all of this data out of these transactional systems. And he is now considered, well, I consider him like the godfather of modern data warehouses and dimensional modeling. I've got some really good resources in the my resource slide at the end that can get you started and down the Kimball methodology road. So the Kimball method takes a bottom-up approach as opposed to the Inmon, which is kind of a top-down. What that means is that it's business process oriented. So we're not looking at the entire organization. We're going to start by looking at a single business process. And we're going to denormalize that data so that we have faster and less complex read actions or access. So Microsoft has really bought into the Kimball methodology, hook, line, and sinker. So if you are planning on using any of the Microsoft analytical tools like Power BI or analysis services, the Kimball methodology is going to be best if you are using the Microsoft analytical tools. So before I go on, do we have any questions out there, Kevin?
There is a question that came in. So is there a difference between what you're calling an analytical database and a warehousing database?
Is there a difference between what I'm calling an analytical database and a data warehouse database? Is that correct? Did I say that
Correct.
right?
Yeah.
Okay. If for our purposes today, I am not. There is no difference for what I'm talking about today because I'm talking very general, just trying to get people exposed to the idea that it's not transactional. A data warehouse is not a transactional system. It is an analytical system. Does that answer the question?
Yes, thank you.
Okay. All right. Well, we're going to keep going. So whenever we learn something new, there's typically new vocabulary that's associated with it. So some of the vocabulary for the Kimball methodology, the first and the biggest is star schema. That's what everything is based upon, is the star schema. And that's because our facts typically sit, which is our business process, sit in the middle, and it's surrounded by all of these dimensions which describe the fact. And we'll get to those other terms on our list as well. Next, we have granularity. So granularity, it establishes exactly what a single row in a fact table is going to represent. It's the combination of all of the dimensions, which are the things that describe your fact or your business process. Next, we have facts. So I've said this, I've used this term a couple times before. So a fact are the things that you want to measure about your business process. They're the quantitative attributes, and they're typically a numerical item that you want to count. So of your business process. So do you want to count sales? Do you want to count patient visits? Are you counting claims? It's typically a numerical thing. It can sometimes be a date, like with patient visits, but it is typically numerical in nature. Next, we have dimensions. So if facts are the quantitative measures or attributes, then dimensions are the qualitative attributes. They describe what happens in the facts. They're the things that make up your business process. So typically, they are preceded by the word by. So I want to see my sales by month, by plant, by salesperson, by customer. All of those things, those are dimensions. It's typically the who, what, where, when, how, why that describe your business process. Next, we have surrogate keys. So surrogate keys are made up values. They typically, we use an integer or a big integer, depending on the size of your data. And they are used so that we can uniquely identify records without having to rely on business keys. Because if we're bringing data in from multiple systems, the business key might be different data types between those systems, or it might be repeated between different systems. So if we add a surrogate key, we can now uniquely identify those while retaining the business key or the natural key. Next, sentinel values. Sentinel values are super important when you're talking about dimensional modeling. Why? Well, in a transactional system, a lot of times values aren't going to exist when you are querying data and trying to join tables together. So you have to write a lot of left joins, left outer joins. If you are following the Kimball methodology, you will create sentinel values, which are essentially the unknown record. That way, you can use inner joins for all of your joins when you are writing your code to pull the data and not have to worry about missing any data. Because if data is missing, it's going to select the unknown value, which is the sentinel values that you have created. So a lot of people say, well, you know, do I really have to use those words? Well, yeah, you kind of do. That way, everybody knows what everybody else is talking about. It's super important that everybody is on the same page and using the same terms. So this is my favorite way to describe a star schema to somebody. We have a bit of a lag here. There we go. So you'll notice my dandelion here. The dandelion head is the fact. It's at the center. And then all of the seeds that are sticking out from it, those are dimensions. The dimensions are only related to the fact, not to each other. So those little seedlings on that dandelion head only talk to the head. They don't talk to each other. They're not related to each other at all. Next, we need to talk about granularity. So before you do anything else, you need to define the grain of of the business process that you're trying to analyze. Now, I've tried to get away with saying, oh, you know what? We don't really need to define that because I kind of got an idea of what they want. So no, we don't really need to define that. Well, let me tell you what, every single time I've done that, my future self has come back and said, what in the heck were you thinking? Define that grain. It helps control the scope of your data and helps you define what you're actually going to be using. Now, granularity has, essentially, there are three fundamental grains for granularity. You have transactional, you have a periodic snapshot, or you have an accumulating snapshot. So you can decide, so if we're talking about sales, we want to see sales down to the day. Do we care by the hour? Probably not. But we need to find that out. The only way to figure out what your granularity is to talk to your business. That is the only way. You can guess all day long, and you know what? 99 out of 100 times, you're going to be wrong, or you're going to miss something. So you have to talk to the business. And when you're doing this, you need to focus on the lowest level, or the atomic level. Go to the very smallest level of detail. And then, because you can always roll up, but you can't drill down if you don't have that detail. And the next thing about granularity that is super important is don't mix those granularities together. What does this mean? Well, if I have two different fact tables, one of them can have that transactional detail, that transactional granularity, and the next table can have that periodic snapshot. I don't want to combine those together. So we don't want to mix those granularities, because when it comes to creating measures and getting answers to our problems, if we mix those, we're going to get the wrong answers. So now we need to talk about facts. So the facts are typically the long, skinny things. They have a whole lot of rows, but not a whole lot of columns. And facts can be additive. These are things that can be summed up across all of the dimensions in your fact table, like a sales amount. Whereas semi-additive is just what it sounds like. It cannot be added up across all the dimensions. A good example of this is right now I'm working on a client that has, they're an insurance broker. And we need to be able to pull in, one of the things that we're working on right now is their accounts receivable and their accounts payable. One of the things that we have to look at is what is the last payment that that client made, and what was the date that it was made. Well, we store that in our fact table, but it's not additive across all of the dimensions because it's very specific to the client. So it's semi-additive. We don't want to add it up all across all of those dimensions. Next, you have non-additive. So these are the things like ratios or percentages. You typically aren't going to add percentages up or ratios up. If that is how your data is delivered to you and you don't have access to the underlying data that produces those ratios or those percentages, just make it known that this is a non-additive fact in here. And but if you do have access to the data, the raw data that creates those ratios or those percentages, I would recommend bringing those in as opposed to the actual ratio or percent, and then you can calculate them yourselves. Lastly, we have factless facts. So factless facts are when there's no actual numeric measure associated with this. So this is typically like we're wanting to count occurrences. So a university, they want to know how many, the students that attended a class on a certain day in a certain building with a certain professor. There's no numeric measure associated with that. It's just the act of the occurrence itself. So that would be a factless fact. Next, we have dimensions. These are the short, fat things. Dimensions are typically, they don't have a lot of rows, but they're super wide. They have a lot of attributes that describe our business process. Of course, we have multiple kinds of dimensions. You have conformed dimensions. So remember when we talked earlier about the business processes, how you pick up different business process and you define what it is, and then you build the dimensions around it? Well, you do that for every business process in your organization. And conformed dimensions are those dimensions that can be used across, or that are common across all of those business processes. So again, the client I'm working on is an insurance broker. Well, something that's common, a dimension that is common across all of their business processes, is a policy. Makes perfect sense. It's an insurance company. Everything, it revolves around a policy. So that would be a conformed dimension. You have degenerate dimensions. Now, degenerate dimensions are things that don't really have, they describe the fact, but they don't really have any legs to stand up on their own. So an example, I was talking about how we were doing the accounts payable and the accounts receivable. Well, typically in a situation like that, you have an invoice header that has invoice lines associated with that header, or with that invoice. So you have a header and a detail record, or multiple detail records. And once you get all of the attributes from the invoice line, all that's really left is just the invoice number itself, which could be a legitimate attribute, but it has no place to live. It can't stand by its own. So you actually add that column to your fact table, and everybody acknowledges that it's an actual degenerate dimension on your fact table. Next, we have junk dimensions. Junk dimensions are those things where you have miscellaneous or low cardinality flags or indicators. So instead of creating a separate dimension for every single one of those, take the Cartesian product of those things so that you can get a common base for what occurs together, and use that and put it in a junk dimension. Now, if you have a lot of different values in those indicators, you probably don't want to do a Cartesian product, because that could get really big really fast. And remember, we want those dimensions to be wide, but not a whole lot of rows. So in that case, if you do have a lot of values that you're working with, try looking at just the ones that exist in your data, load those to begin with, and then as part of your subsequent loads, every time you load data, look to see if there are any new combinations that exist, and if there are, go ahead and add them to your junk dimension. And then lastly, when we talk about dimensions, we have slowly changing dimensions. So slowly changing dimensions, all that means is, do we want to keep the history of this? If data changes, do we care? Well, I don't know. Maybe we do, maybe we don't. This is another situation where you need to go back to the business and you need to ask them, do we care about the history of our customers? Do we care about the history of our products? The two most common are type 1 and type 2. Type 1 is where we don't care about the history. If changes come through, we're just going to wholesale overwrite everything in that record, and now it's all updated and all that history is lost. Type 2 is when we do need to preserve that history. So if you do have to preserve that history, in addition to the attributes that you have already created for say, example, your customer, you're also going to need some additional columns in there. You're going to need an effective date, an end date, and an is current flag. Those are going to help you so much when you're trying to find the current records and when you need to go back in time to see what it looked like last year as opposed to this year. And the last thing that we need to talk about a little bit more in detail is the surrogate keys. So like I said, they have no inherent meaning. These are things that we have just made up. Typically, in a SQL Server system, it's just an identity column. You use integers, it auto increments every time you insert a record. And it allows for repeated natural keys without any conflict. So again, if we're pulling data from multiple systems, and system A has an alphanumeric as their natural key data type, and system B has just numbers, well, that also fixes it, because we can just store it all as character data, but we can use the surrogate key to uniquely identify it, and we've preserved the natural keys without any conflicts. So that's all of it for talking about the definitions. Do we have any questions out there?
Yes, two
Okay.
questions, one of which is probably fairly easy, and one of which is a can of worms that I may have accidentally opened.
Oh, thanks. I'm going to take a drink while you read the question.
All right, so first question. Are there design patterns for business models that can be used for modeling similar to the Inmon resource book?
Um, I'm sure there are. I'm going to be really honest. In the 10 years that I've been doing data warehouse work, I have never encountered an Inman model or a situation where an Inman model was going to be more useful than the Kimball method. So I do not know. I'm sure Kevin, you've been around a whole lot longer than I have when it comes to BI type work. Are you familiar with any?
So the one that I threw out, so this was sort of I took the question as the Inman model approach has a data modeling book, and what would the equivalent be on the Kimball side? And I came up with the data warehouse toolkit.
Yes, yes. And that's what I use. I have a copy on my shelf within easy reach when I'm sitting at my desk. It's very well used.
Yeah. Now the other side was a bit of a discussion about Data Vault.
Oh,
And do you know of any good material, reading material on the Data Vault method?
I do not. I know, it's kind of one of those things. It's new, it's shiny, it's fancy. And when I say new, yeah, okay, I realize that came out in 20 years ago. But it's just started gaining ground about 10 years ago. Again, I've been doing this for BI work for 10 years. I haven't run into it in the wild. I'm not super familiar with it, but Google in that case would be my best friend, and that's how I would learn about it if I were searching. If you've got any resources for Data Vault, I gladly let you share them.
Yeah, what I thing I pointed out was kind of interesting that Data Vault is pretty popular in Europe. I have never heard of
Oh,
anybody doing a Data Vault in the US, which
okay,
of course there are people who have. I lay
sure.
that out as a just given. But of all the BI professionals that I've known, only the Europeans ever really get interested in Data Vault and they love it. And then you go to the US,
Okay.
it's like, nah, Kimball's fine.
Yeah. So, I mean, I understand its use cases are more for when you're dealing with big data, unstructured data, because it keeps that lineage and it does all of that. To me, it becomes way more complicated than it really needs to be. And why do we need it to be that complicated? And, maybe there are good reasons for it, but in my career, I have never run into a situation where I've needed it. So,
Sure. Last question here.
okay.
How are people fitting subscription data to a star schema? A lot of businesses are subscription based with through and from periods, not necessarily based on a particular date.
Okay. Well, so you still have so you have subscription data and you're trying to model that. Is that and how would you model that? Is that essentially the question?
Yes.
Okay. Well, with a subscription, I would assume that you do have a start and end date. That's kind of the nature of a subscription, isn't it?
Yeah, yeah. So you do have start and end
Okay.
dates,
Yeah.
and it's more of the fact that you have periods of time as opposed to individual dates of events.
Okay. Well, so one thing that every star schema needs is a date dimension, or some kind of temporal dimension. So whether that be actual dates, whether that be time, um, and what I do if I can't find exactly what I'm looking for, if I run across something that I have never had to model before, I go out to SQLBI.com, affectionately known as the Italians, because if I haven't modeled it, I'm pretty sure they have. So that would be where I would go. I've never had to model anything like that before, so that's where I would start. Have you had to model stuff like that?
I have I've done it a few different ways over the years, and I think the way that I'm landing on is essentially saying that yes, it is subscription data, but I'm still going to treat it as an event stream.
Mm-hmm.
That kind of treating it like a Kafka topic, where I'll parse through the event stream as needed in order to get the relevant information that's going to show up in queries. But I think a lot of it depends on how you're going to use the data.
And that's a really good point. How is that data going to be used? What are you, what is its use case? How is it going to be consumed? And that's actually going to drive a lot more of your data model than anything else.
All right, so that was all of the questions so far.
Okay, all right. Well, let's keep going. So we defined what data modeling is. Now let's talk about some of the benefits that you can get from data modeling. So if you do it correctly, the biggest benefit that you're going to get is flexibility. So, and when I say flexibility, you need to be able to support different granularities. Now, when we talked about granularity earlier, I said don't mix granularities. And that is true. You don't want to mix different granularities in the same fact table. But if you know ahead of time that you are going to have to support different granularities, create different fact tables to support each of those granularities. Typical example, sales are typically aggregated on a daily basis, but budgets and forecasts are typically done on a monthly basis. So if you support those different granularities in two different fact tables, daily sales can always roll up into monthly sales, and then you can compare them, and you're comparing apples to apples. But if you mix them in the same fact table, you can't do that. So if you support different granularities via different fact tables, you're going to get a whole lot better flexibility with your system. The other thing about data modeling, or about dimensional modeling, is that it's a lot more intuitive for your users. You want to use their business vocabulary. The whole point of creating a data model, a dimensional model, is typically for somebody to be able to write a report against it. Well, if you use their business vocabulary, they're going to use it. If you use obscure names or things that don't mean anything to them, it's not going to do any good. That brings me to the next thing, which is you need to use friendly names. Put spaces in there. Spell words out. Don't abbreviate things. Make it user friendly. Use their vocabulary. Use friendly names. The other good thing is that with dimensional modeling, the keys are hidden. Oh, look at that. Typo on my screen, on my slide deck. So that's supposed to say keys are hidden. I have no idea what happened there.
I think you might have done a global copy replace of ID to key.
I think I did.
Although I thought it was kind of funny, especially if you make it an animation.
There we go. So that's another really big thing about dimensional modeling is you hide those keys from the users so that they are not confused by that, because they see something. So again, I'm talking to the client I'm working on is an insurance brokerage. So they see policy ID, they think, oh, hey, yeah, that's the policy ID I want. No, 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 no. So make sure you hide your keys, causes a lot less confusion. And then your relationships, you create them only between your facts and your dimensions. So it makes it a lot more intuitive on how that data is supposed to be used and how it fits together. Next, you're going to get faster processing. And the reason that you're going to get faster processing is typically because you get really good memory compression for columnar data. So if anybody is out there that's familiar with the Vertipack engine or the column store, so we went from that, relational view where we didn't repeat data to the denormalized view in our analytical database where we're repeating values again. Well, now that we're repeating those, we can compress that stuff a whole lot better, and compression leads to faster processing. And the last benefit that you get from dimensional modeling is you get less complex code. If somebody sat you down in the cockpit of this airplane and said, hey, fly me somewhere, and you were not a pilot, you would take one look at that and say, yeah, not gonna happen. Well, same thing happens if you are dumped into a relational database and somebody says, hey, write me a report on sales by month for customers in the last whatever for these products. You are most likely going to be looking at a really big database schema that's got hundreds of tables in it. And you would not even know where to start. So with dimensional modeling, you're typically just one join away from getting an answer, and that leads to much less complex code. So those are the benefits that we see from data modeling. Do we have any questions out there?
None at this point. There is some love for the VertiPack engine, though.
Okay. Yay, VertiPack. All right. Well, now let's go through a really simple example on how to get started with data modeling or dimensional modeling. So our mission, which we have chosen to accept from our boss, is to write a report on our sales, create a data model for our sales so that we can do reporting on that. And this is the relational, a picture of the relational database. And you're like, oh man, I have no idea how to get started with this. Well, luckily, Ralph Kimball actually provided you with a way to get started. He actually has a methodology for getting started. Start with selecting the business process. Well, that was already dictated to us. We want a data model for our sales process. So you need to declare your grain. Remember, that's the first thing you do after you decide what your business process is you need to declare the grain. You need to establish exactly what a single row in that fact table is going to represent. Keyentify the dimensions. So that is supposed to be identify. I guess I didn't find all the places where I did a global search and replace. So that's supposed to say identify dimensions. These are the things that are typically preceded by the word by. Those are the who, what, how, when, where, why. Those are the qualitative things that describe your business process. And then again, Keyentify those facts. Figure out what you want to measure. What are you trying to measure here? So, like I said, we have already selected our business process. That was dictated to us. Somebody said, what are, give me a data model for our sales. So that's our business process that we're working with. It's the business. So we've selected our business process. So now we have to declare our grain. So what is a single row in our fact table going to represent? Well, we go back and we talk to the customer and they say, well, we want to know the sale of a product on a date to a customer in a store by a salesperson. So we take that statement and we say, okay, that is our grain. That is what we want to, that's how detailed we want to be with our business process. So now let's identify those dimensions. So that really just, now we're gonna keyentify those dimensions. So again, that's the who, what, where, when, how. So the first one, who, that's our customer. So remember, it's the sale of a product on a date to a customer. So there's our who. Product, the sale of a product, there's our what. So the store, the sale of a product on a date to a customer in a store. So that's our where. Date, when. So the sale of a product on a date, that's our when. And by a salesperson, that's our how. So now we've identified those dimensions that we want. Now we need to move on to identifying our facts. So what are we trying to count or measure? Well, we're talking about sales, right? So what are some of the things that we would try and count or measure when we're talking about sales? So, well, how about just what are our sales? How much did we sell? You know, so whether that be by month, by date, by customer, by product, what are our sales? Another thing, well, how many products did we actually sell? That's something else that we could count or measure. How many customers do we have? That's another thing that we can count or measure. What is our sales margin? That's a really important one if you're selling stuff or if you're manufacturing things. So if we take all of those and we put it all together, so we're going to take our granularity, we're going to take our facts, and we're going to take our dimensions, and we're going to put it all together so that we can create a star schema. That is our goal. We want to create a star schema. So we're going to start with our sales table, and we're going to put it right in the middle. And you'll notice that we have a bunch of key columns in our sales table here. And then at the very end, we have units sold. That is a numerical measure. So let's go ahead and add. So there's our units sold. So I realize that there's kind of a little lag between what I say and when it happens on the screen for you guys. So sorry about that if it seems a little bit out of sync. It's kind of like watching a foreign film that's been dubbed into your own language, and they talk, it looks like they talk for 10 seconds, but they only said 2 words. So think of it as when you're watching a foreign film right now. It's much more entertaining. You can get some popcorn too. That'd be really nice. All right. So now we're going to add our customer here. So we've got our customer key, and you'll notice I have this little and I don't think it shows up on your screen. So let's add the next one. So then we have our product table, shows up over here. And you'll notice I have this little SK in parentheses. That's our surrogate key. But you'll also notice that I have a little BK next to the product SKU. That's our business key. That's our natural key for that dimension. But that product SKU, because we're pulling from multiple systems, it's not necessarily unique among those disparate systems. That's why we need the product key, which is a surrogate key. It's a made up number. It has no intrinsic value other than it makes our record unique. So now we're going to add our store. We have our store key, and of course we have 2 store keys because I did a search and replace on ID. And then we have a date. So we can see our sales by date, by month, by year. And my little ellipsis, my little dot, dot, dot means we have other columns in that dimension. And then lastly, we have our salesperson. And this, again, we have our surrogate keys and our business keys. And all the business keys should have ID instead of key in there. So I need to go back and modify my slide deck because I evidently, like I said, I did a global search and replace and I didn't mean to. I meant to do it on one slide. So I will fix that. All right. So now when they ask you to create a report on your sales data, which one of these do you think you're going to use? Which one is easier? I think it's a no-brainer, but I could be wrong. I think the one on the left. We've used friendly names. We have our fact in the middle. We only have 5 dimensions. But the thing on the right-hand side, that's like crazy town. I would not want to write a report against that if I had to. So in short, if you are going to use Microsoft analytical tools, you want to star schema all the things. You're going to get better performance, and they work better with the Microsoft tools. So a lot of times I get kind of stuck and I start going down a rabbit hole. So I have 2 questions that I ask myself. So the first one, when I start down this rabbit hole, is I come back and I say, what do you want to count? Do you want to count my sales? Do I want to count widgets, or what key gets? I really got to fix that. Those are going to be your facts. What do you want to count? Those are your facts. The second question I ask myself is, well, how do you want to count it? So do I want to count it by date? Do I want to count it by product? Do I want to count it by customer? Do I want to count it by store? These are all of my dimensions. They're preceded by the word by. That's my go-to. So whenever I start going down that rabbit hole, I always come back to these two questions. What do you want to count? How do you want to count it? That brings me right back out of that rabbit hole, and I can say, okay, Uncle, I'm done. All right, we have one last concept that we need to talk about, and that's snowflaking. So for me, as a former DBA, this was the hardest habit for me to break. So snowflaking is where you use dimensions that describe dimensions. So essentially, you have relationships between dimensions. But remember, one of those rules of the star schema and dimensional modeling says you only have relationships between facts and dimensions. So snowflaking is when you have dimensions that describe other dimensions. So super simple example. We're going to stay with our sales example here. We have our sales table on the left-hand side. We have our product in the middle. That's our dimension. And then we have two other dimensions on the very right-hand side, segment and category, that both describe the product. So product is related to the sales table with the product key. Then you have segment, and that's related to the product key or the segment key in the product table. And then last, we have the category table, which is related to the product table with the category key. So this is a snowflake. We have dimensions describing dimensions. So we need to make that go away. We don't want that. We need to get rid of that. We want a star, not a snowflake. So how do we do that? Well, let's just take the columns from our segment table and drop them into our product table. When we do that, or after we do that, now we can get rid of that segment table because we've added all of the values to our product table. And now we can get rid of the segment key out of the product table because we don't need it anymore. We have the actual attributes of segment as part of our product dimension. We're going to do the same thing for category. Take those category attributes, add them to the product. Now we can get rid of the category table, and we're in the product key or the product table. Now we can go ahead, because we already have those category attributes in there, we can get rid of the category key. No more snowflake. It's all gone. So this is a very super simple example, but it gives you an idea of how you would overcome something like this. Snowflakes are bad. We want that star schema if we're using the Microsoft analytical tools. And that's how I get started when I work with dimensional modeling. I've got the session feedback here. So while this is up, do we have any other questions out there, Kevin?
There was a comment about how it's really important when thinking about distribution keys that things like Power BI or the Vertipack engine don't really give you much room for specifying how your data should be distributed, but it can still be important for, say, in-memory databases. And my follow-up was, or for Synapse Analytics.
Absolutely. Absolutely, it can. So you can either use your smartphone to scan this in. Kevin has put the link in the chat there for you. This is my own. Again, if you liked the session, great. Tell me what you liked about it. What made it good? If it sucked, I'm sorry. But what else did you really have to do on a Saturday night when everybody's in lockdown? So, but if you didn't like it, or if you thought I could improve it in some way, shape, or form, please let me know. I can't see your faces, so I don't know whether you guys are sleeping, whether you're just listening to this in the background while you're watching that foreign film. I don't know, maybe I was the soundtrack to your foreign film tonight. With that, here is all of my contact information. I want to thank everybody for coming out on a Saturday night. It's always super exciting to see people who want to further their career on their own time, because to me that tells me that you really are interested in your career and you want to learn. So on Twitter, I have my own blog. I am on LinkedIn. Just a quick note on LinkedIn: if you reach out to connect with me on LinkedIn, please tell me where you saw me or heard me in this case. LinkedIn is kind of a weird place for a woman in technology. So just that being said, just let me know where you saw or heard me, whatever. Again, I have resource slides. I will make my slide deck available. It will be on my website, which is with SQLswimmer.com. If you go to the presentations page, I'll tweet it out as well so that you have a direct link to that. And that is all I have.
Great. There's another question that came in, which is, well, what about normalization? Like if we put segment code and description and category code and description into the product table, wouldn't that violate the concept of normalization? And does it matter?
Well, it absolutely would. But remember, we're not trying to create a relational database. We're trying to create a dimensional model. We are not trying to normalize this stuff. We want to make it easy, super easy. We want to be one join away from getting an answer. So when you're creating a dimensional model, no, we don't care about normalization, not at all.
Yeah, and if I would add my own little bit of kibitzing on here.
Sure.
One of the key things that makes this Kimball style work is that there is exactly one way to get data in. Nobody else is allowed to change the data other than the proscribed data loading process. So one of the major benefits of normalization is that as a lot of different people through a lot of different processes update data, they may not necessarily know all the places to update. So a benefit to normalization is you have one place to update. But with the Kimball model, because there is a single entry point for any data change, you can have data replicated or copied out into a lot of different columns and spread out a lot flatter than you would normally see in a relational database for the performance benefits that Angela is talking about.
Yep.
So how do you manage data changes?
So how do you manage data changes? So are you talking about dimensions, or are you talking about facts? Do we have a context?
The specific point here was say the date dimension, but yeah, let's say dimensional changes.
Okay, so you go back to your business and you say, do we need to keep a history? So if we're talking about a sales database, and depending on what our product is, we may care that somebody has moved from Colorado to North Carolina, and because they did that move, they no longer need snowshoes. They live in North Carolina now, so they might want to find out why that person is no longer buying products that relate to snowshoes. If that is the case, then you would need to use a slowly changing dimension, and you would need to talk to your business to find that out. And that is one of the really key takeaways when you're doing dimensional modeling. You have to talk to your business users. It's a business process. You are IT people. I don't know about a lot of you, but I don't know a lot about ins and outs of a lot of different business processes. So I have to talk to my clients to find out, how are you using this data? What is your end goal? How is this going to be consumed? I have to have those answered before I can go on. And I'm really lucky in the client that I'm working with right now. We have a really good relationship, and I can just call them up and say, hey, you know what? I'm looking at the data and it looks like this. Can you explain this business process to me so that I can make the right modeling decision? And they're like, oh yeah, it works like this. And that's how I make that decision.
Okay. And there's a follow-up, changes to a product from one SKU to another. So let's say there was some product gets rebranded as a new SKU, a new variant of the same product.
Mhm.
What about that historical data?
So again, if you have created if you modeled it as a slowly changing dimension, you're going to have those additional attributes on that dimension that have a start date and an end date, and then you're going to use that flag as well that says, is this a current product or not? So you're not going to lose that historical information because you're using because you have updated that. So if you want to track that historical information to that sale, then you would definitely need to do that. Does that make sense?
Yes.
Okay.
Does make sense. And one last follow up, because I guess it's one other route that we could take with the question,
Okay.
is what happens when the old data was incorrect?
What happens when the old data is incorrect? Well, that never happens to me. I always have pristine data, so I don't know what you guys are working with, but so what happens when the old data is incorrect? The best place is to modify it in your source system. If we are making changes, this is one of my design patterns that I use. I use hash bytes to see if data has changed. So I take a combination, if you're not familiar with that, I take a hash of all of the data values in a row, and I add that as an additional column. And then I can just compare those two hash byte columns together to see if there are any changes. And if there are, then I can update them. So it just kind of comes back to the word just went right out of my head. I don't think I've had enough caffeine, and it's almost 8 o'clock here. So
It's true. It's getting there. All right. Well, wonderful. So, as we wrap up this session, thank you again so much, Angela, for a great presentation.
thank you
If
very
you
much, and thanks again for having me.
Absolutely. If you have not filled out the form, I'll drop one last link. So please fill that out for Angela. We are going to take a short break, a very, very tiny stream intermission. We'll be back on at 7:50 as we get to our next speaker, Hassan Savran, who I thought I heard him ringing the virtual doorbell already. So I'll cut the stream for just a second. It'll be back up, and then we will get rolling again in just a moment. So stay tuned, everybody.